Hello and welcome to this video in which we shall attempt to discuss second degree log equations. So log equations with x power 2 with quadratics. Again, our purpose in solving any problem is to isolate the x. We have two logs here, and using log laws, we are allowed to concatenate this into a single logarithm. So we have log base 7, and then we have x squared plus 6 multiplied by, divided by 3x plus 4 because we have a minus here, and using log laws, this means that we can divide both terms, and this is all equal to 0. Now, to get rid of the base, we can write 7 as a base here and 7 as a base here. So the 7 cancels the log base 7, and we are left with x squared plus 6 over 3x plus 4 equals 7 power 0. 7 power 0 is 1. You can take the denominator to the other side. So we have x squared plus 6 equals 3x plus 4. You can take everything to the left. So we get x squared minus 3x plus 6 minus 4 equals 0. This becomes x squared minus 3x plus 2 equals 0. And you can use mode 5.3 on your calculator. I'm just going to factorize because it's faster. So x minus 2, x minus 1 equals 0, x equals 2, x equals 1. You can use your calculator to find the two values of x. Finally, we have to check that the two values of x are indeed correct. And the way to do that is to create a small table with the expressions inside the logarithms. So x squared plus 6 and 3x plus 4. We're going to check these two expressions for the two values of x. The two values of x are 2 and 1. So x equals 2, x equals 1. The purpose of this check is to make sure that the value of x does not yield a negative in the expression. So if we put 2 in this expression, we get 2 power 2 plus 6. This is 10, so this is okay. If we put 2 in here, it's 3 times 2 plus 4. Again, this is 10, so this is okay. For the 1, we have 1 power 2 plus 6, which is 7. Here we have 3 times 1 plus 4. Again, this is 7. We don't really care that the values are the same. We just care that they're positive. So for the 2, this is okay and this is okay. So the 2 is accepted. For the 1, these are both positive. So the 1 is accepted as well. So both solutions are okay. I'm going to put 2 here and 1 here, or vice versa. It doesn't matter. And this is the correct answer. Let's try another problem. So again, you can just concatenate into a single expression. You have log base 2 x squared plus 7 over x plus 5 equals 3. And you can get rid of the base just using a base of 2. So 2 cancels log base 2. You have x squared plus 7 over x plus 5 equals 2 power 3, which is 8. So this expression here is the same as 8. 2 power 3 is 8. So we have 8 here. We can cancel this out, and we can just put it here on the side as a bracket. We have x squared plus 7 equals 8 times x plus 5. So x squared plus 7 equals 8x plus 40. We take everything to the left-hand side. We have x squared plus minus 8x first, and then plus 7 minus 40 equals 0. So x squared minus 8x minus 7 minus 40 is minus 33. And that is equal to 0. So we want two numbers that multiply to 33 and subtract to 8. Again, you can just use your calculator for this. My two numbers are x minus 11, x plus 3 equals 0. And we can just figure out the values of x, which are positive 11 and negative 3. So we can use the table to check for these values. We have x squared plus 7, and we have x plus 5. You want to check for x equals 11, x equals 3. You don't really have to compute the values. You can do it by eye. So 11 squared plus 7. Obviously, these are positive. So the value here is bigger than 0. It's a positive value. That's all we care about. We don't really care to know what the number is. Same thing here. 11 plus 5 is definitely a positive value. So this value here works. For the negative 3, I forgot to add a negative here. We can check it as well. So we have negative 3 power 2 plus 7. This is 9 plus 7. So again, this is a positive value. And for the second expression, we have negative 3 plus 5, which gives us 2, which is again a positive value. So the negative 3 works as well. We're going to create another solution box here. We're going to put 11 in the first and negative 3 in the second. So this is fine as well. Let's try a third problem. We have log base 4, x squared minus 1 minus log base 4, x plus 5. So we can put them as a single logarithm. We have x squared minus 1 over x plus 5, like this, and this is equal to 1. You can put 4 as a base on both sides. These will cancel out. So we have x squared minus 1 over x plus 5 equals 4 power 1, which is 4. You can take the denominator to the left, to the right, I mean. So 4 times x plus 5. And we can distribute the 4. This gives us x squared minus 1 equals 4x plus 20. We take everything to the left-hand side. So x squared minus 4x minus 1 minus 20 equals 0. X squared minus 4x minus 21 equals 0. Again, you can use mod 5.3 on your calculator or just factorize. So you get x minus 7, x plus 3 equals 0, x equals 7, x equals negative 3. Now we need to check for the two values. So we have x squared minus 1, x plus 5. And we're checking for 7 and negative 3. So this is 7 power 2 minus 1. This is obviously a positive value. It's 48. And here we have 7 plus 5. Again, this is a positive value. Negative 3 power 2 minus 1. This is 9 or minus 1, which is 8. So again, a positive value. Here we have negative 3 plus 5. And again, this is a positive value. So both of these values would work. And I would just add a solution here. Put 7 and negative 3. And this is correct, which brings us to the end of our video. I hope this has been beneficial. Thank you for watching.